It says, "Now faith is being sure of what we hope for and certain of what we do not see. This is what the ancients were commended for." And this is the part we're keying in on. By faith we understand that the universe was formed at God's command, that God spoke and he commanded and the universe was formed by God's command. So that what is seen was not made out of what was visible. And without faith it is impossible to please God, because anyone who comes to him must believe that he exists and that he rewards those who earnestly seek him. And so there's a faith issue, because we serve, the Bible says in many places, a God that is invisible to us. He's not, his being isn't right before us. And so it takes faith to believe in him, and our faith is built by looking at the creation that he has made, by looking at the cosmos we studied in week 1. Week 2, we studied the creation, the nature around us. Week 3, we talked about the human body and how that shows design. Last week, we talked about a single cell and how that shows design. And we can look at the world around us and everything that God has made. We can look up at the stars, and our faith of what we can see can build the faith of what we can't see. This invisible God that we serve has created so that we can see the things that he's made, so we can know he's there. And our faith is built by studying and looking and appreciating that creation. By faith we understand the universe was formed at God's command, so that what is seen was not made out of what was visible. That this invisible God has created all this stuff for us to enjoy. He's given us a mouth to taste. He's given us ears to hear, a nose to smell, eyes to see, and hands to touch and feel the creation that he's made, so that our faith can be built in him. And that's pretty cool, right? Well, today I'm not going to talk to you. We've had somebody different every week jump up here for a little bit, but today I'm going to hand the whole thing over to somebody that I love very much and is a good friend of mine, and also my boss one day a week, or maybe one day every 2 weeks, I don't know. But I'm going to ask Mike Connor to come up, and he's going to speak to us about another way that we can see design in bees and trees, and I can't imagine anybody better to talk about this than him. So, and I'll put you over there. It's easier. It's better. I just need the microphone, so I'll put you over here.
Yeah. All right. Okay. Is this thing working? Hey, that's fantastic. Hi, everybody. I'm Mike Connor with my wife, Vicki. Most of you know me. For those who don't, I am an arborist. I'm a tree doctor. I'm a horticulturist. If it has to do with plants, I do it. And that's my background. And Tony does help me every other week or so, depending on his schedule with the church. Okay. All right. Tone her down a little bit. Test, test, test. Anyway, while they're getting that ready, Tony's been a big help, and he's also a good friend. So I stay in touch with FaithWay. I make him give me a report every time I see him. And it sounds like you guys are doing very well. So that's fantastic. Tony has helped me quite a bit. First of all, his brother-in-law designed this T-shirt. Pretty cool. Yep. Save a bee, plant a tree. And I've had the opportunity to give quite a few talks to beekeepers and arborist groups about the necessity of trees and their relationship to bees, because most everybody doesn't have a clue, including beekeepers and arborists. So that's really significant. Trees are the most important source of nectar and pollen for bees, whether they be our domestic honeybee or wild bees that we have in the entire Midwest. And people just don't know that. We just cut down trees and just don't think about it. But it's very, very important. So today what I want to talk about is, Tony asked me to talk about a topic of which I am not that well prepared, but it will be design. And by words of confession here, I used to be a very strong evolutionist. So I have converted. And I am now a very strong creationist. And that was done, what I think, intelligently, without the emotion, but simply looking at the facts. And I want to talk a little bit about that journey today. I don't want to talk over anybody's heads. I don't want to talk under anybody either. This can be a really fast talk. You know, if nobody reacts, it's going to be a really fast talk. We're going to be back there to the coffee quickly. So if you have questions, please ask. You know, that's what it's all about. I want interaction going on here. just a couple technical terms here. Adaptation is, or natural selection, those are terms that we are afraid to use as Christians. And we look at the term adaptation or natural selection and we run away from it because we think automatically of evolution. Well, the fact is that adaptation and natural selection, they're in place. They work. I mean, that's how the world works. And the problem is that evolutionists have hijacked that word and they say that any adaptation is evolution. Absolutely is not. And so, rather, adaptation is a mechanism that allows organisms to adapt to their environment. And think about that, before we really get into the slides here, think about that if you are an elephant or an elephant-like creature and the world warms up and you're all covered with fur, what are you going to do? You're going to die. You need to be able to adapt. So you're going to, the elephant with bigger ears that have, act as radiators, they can live in that hotter climate. Or if the world cools down, the elephant that grows a lot of fur and gets really ornery, they're still elephants, Mastodons, mammoths, and elephants genetically can still all interbreed if we had them. So they're really the same. But that's not evolution, that's adaptation. Okay, and I'm sure Tony's gone over all that with you. All right, so I just want to take a minute and review really quickly your biology textbook. So go ahead. Biology textbook, the pepper moth. Who hasn't heard of the pepper moth? All right, well, the pepper moth is the typical, expression of evolution in your science book. It's like, oh, well, the pepper moth proves evolution is occurring because this is the pepper moth. Next slide. And you can see it, it's on the right there, and you can see it up against a tree, and birds don't see it, predators don't see it because it's camouflaged. But in England, where the pepper moth is, the trees are turning black because of pollution, and suddenly there appeared a black pepper moth. Next slide. And that's the black pepper moth. So right away, taxonomists gave it its own species name. They now called it blah, blah, blah nigra because it's a new species. Evolution has occurred. Funny thing is, they still interbreed freely. I mean, it's still the same moth, but they're all excited because it's a new species. So we're going to call it a new species because we can. Next slide. Now, there's actually a pepper moth on the left on a black tree. Do you see it? Neither do the birds. So it's adaptation. Very, very simple. If you're a white pepper moth, what's going to happen? Birds are going to come and eat you. It's not evolution, it's adaptation. Okay. And of course, another example are the finches that Darwin promoted at in those islands. Galapagos? Yeah. And those islands off the coast of South America. And he was startled by the way the finches had adapted to the different niches on the island. And he was so impressed that the niches had evolved different beaks. So some could eat seeds, some could eat worms, some could eat little crabs, some could eat whatever they found. Go ahead. In fact, there's a chart. Yeah, I know it's boring. Go ahead. And he said, well, that's evolution because all these finches have gone into a different niche and they've turned into something else. They still interbreed. They are still finches. And this is not evolution. We can call it microevolution if you want to, but it's still adaptation. And then they look at this. This was not a monitor, but it's a lizard and an iguana on the island. And, well, you know what? There's not a lot of food on those islands. So this iguana returned to the sea. Okay? It evolved and became a sea-dwelling creature again. Well, it's still an iguana. Still interbreeds with the land iguanas. It's just that this one learned to take advantage of a niche and it goes down into the ocean, eats algae and seaweed, comes up, grabs air, goes back down. Still 100% iguana. Okay. So what we need to do as those who believe in creation, we need to believe that adaptation occurs and it can occur rapidly. Let's embrace that. Let's not be afraid of that. It's not evolution. We believe that this kind of process would have occurred rapidly after the flood, blah, blah. Such effects are largely responsible for generating the tremendous diversity we see in the world today. Okay, next slide. All right, so let me tell you a little bit about my personal journey, because I think that has relevance here. Okay, personal journey, cool photo. Long time ago, a Christian man said to me, we were discussing evolution and creationism, and of course I was an evolutionist. And he told me to consider, just consider the facts. Quit the emotion, take the blinders off, and look at both sides of the issue without bias. Christian man told me that. He was just an average Joe, just a nice guy. So I went to a meeting, let's see this. I went to a meeting where Dr. Dwayne Gish, who's from Kalamazoo, was speaking. He later became very involved with the Institute for Creation Research. He was a research microbiologist for the Upjohn Company. Strong Christian, strong creationist, and would defend creationism to anybody at any time. In fact, he would debate anybody at any time, and he set up a series of debates across the country, and he would debate with any college professor or any scientist who wanted to debate him, and he never lost a debate, simply based on facts. When it turned into emotion, he would lose. But because the other side would always turn it into an emotional, this is a religious thing, and he would say, I don't want to talk about religion, I want to talk about facts. I actually met him. And next slide. And his point was, what do you expect to see? If you remove the emotion, I'm sure Tony's talked to you about this. What do you expect to see in the fossil record? He had a book called Evolution, the Fossils Say No. And he said, quit your preconceived ideas. If evolution is true, what do you expect to see in the fossils? If creationism is true, what would you expect to see in the fossils? So you look at the fossils, and guess what? It's creation, hands down, no question. There are no transition forms. There are no intermediate phases. There aren't any lizards with half wings turning into birds. It's lizards, it's birds, it's frogs, it's mammals. No transition forms. And no transition forms to date have ever been found, despite the claims of evolutionists saying, oh, all these transitionary species exist. There aren't any. There are none. I remember recently I was reading an article about this great transition they found between an ape and man, and then they discovered, oh, sorry, it was a fake. And, Piltdown Man was a fake. It's amazing. And so if creationism is true, what would you expect to find in the fossil record? Okay. Yeah. Yo. They're always made quickly. Yeah, Wayne Kaiser, if you remember Wayne, he lived in Bradley. He worked at a coal mine for a while. He worked for an excavation company, and he was digging coal out in Virginia, I guess. And the things they would find in the coal, and he was a quasi-creationist. I mean, not real serious, but they would find like trees growing up through all these layers of coal. And they had fossilized. And he's going, well, how can that be? I thought that it took coal millions of years to form. And then when they were out there, and they had a raccoon that they had dug out of the coal. Fossilized raccoon, smashed like this, with coal below it and coal above it. And he said, if this happened over millions of years or tens of thousands of years, how did a raccoon lay there that whole time? I think that's a good question. Had to have been quick, I think.
Well, that was an old ancestor of the raccoons of today. It was the raccoon just that we have today.
It was a raccoon we have today, yeah. Yeah, exactly. Right. So, if you believe in evolution, you believe that what you will see will be, the fossils of paramecium and single-stem bacteria going into man from molecules to man is the term. You don't see that in the fossil record. You don't see that at all. What you do see is you see the single-celled organisms are still single-celled organisms. The fish are still fish. The lizards are still lizards, frogs are frogs. You don't see these transition forms. Men are still men. That's what you find in the fossil record and in history. Okay. So, critical thinking, and this is not Dr. Gish, this was me going, so if evolution is true, what do I expect to observe in nature? Okay, forget the fossil record. What would I expect to see out in nature? And if creationism is true, what would I expect to see in nature? Just leave the emotion, leave your faith out of it. What am I going to expect to see? You know, look at life that way. Okay. And during this transition phase, after I had, somewhere in here I talked to Dr. Gish. I was working at Michigan State at the biological, Kellogg Biological Center down at Hickory Corners. I worked there for 5 years as a research technician working on a project with this critter called the cereal leaf beetle. Cereal leaf beetle, next slide, was a devastating pest in Michigan. Nobody knows that anymore. You couldn't grow oats. You couldn't grow most grains in Michigan because this pest was destroying the crop. And it was an introduced pest from Europe, extremely devastating. The only way you could grow oats was to spray them twice with pesticides, and then suddenly you have more money than the oats are worth. So it was a huge economic blow. This was back in the 70s. Date myself here. So these are the larvae of the cereal leaf beetle, and they will just strip all the chlorophyll out of the leaf, and so the plant can't produce a crop. It has no strength to produce a crop. The oats will be these little scraggly things on top. The wheat will be almost not there. Okay, next one. And this is a single larva of the cereal leaf beetle, and it's stripping the leaf. Now, what's really neat about this, and it was really an eye-opener for me, was that the cereal leaf beetle larva covers itself with its own waste product. Okay? Doesn't drop it on the ground like a normal larva does. Takes it and somehow it pushes it up on its body. So they are sticky, stinky, horrible little critters. And I had to walk through and collect millions of these things. And they would stick to your shoes and your pant legs. And the reason they would do that is because they were totally, totally safe from birds and from predators. Nothing is going to grab a hold of one of these things without spitting it out. They're awful. Next slide. But we discovered this little tiny wasp, size of a pinhead, called Tetrasticus julus in Europe. And this little tiny wasp, its entire life is centered around the cereal leaf beetle. Doesn't feed on anything else, doesn't affect anything else. They're stingless, tiny. One of these little obscure little bugs you see in your windscreen sometime. Absolutely 100% committed to destroying the cereal leaf beetle. Okay. Now, clock, because, not because I'm going over, but because when I was working there, after we got this little wasp established, we discovered that we could predict to the hour when this wasp would appear. I'm still struggling with this whole creation evolution thing, and this guy that I work for, Dr. Gage, he goes, well, the parasitoid will be emerging about 2 o'clock today. Really? I'm out there putting up these traps, nothing. About 3 o'clock, hundreds, thousands of these little wasps were coming up out of the ground. Now, they're in the ground. They have spent the winter in the ground. They have been there since last summer. Why do they come out at this time? Next slide. Because that's when these grubby little cereal leaf beetle larvae are primed to lay an egg on. They are in the ground, waiting. And think about that. They're in the ground, so it's not like it's air temperature. Okay? What triggers this? Literally, Yep, literally to the hour you can know when these things are going to come out. And it's like, I don't understand this. You know, it doesn't make any sense. You know, how these things can happen. And what they do, there's a Tetrastracus Julis, and notice it's got its little proboscis, its little tongue out. And it's tasting it and going, yep, this is terrible. This is a cereal leaf beetle. So it's identified its host, and now it just sits there. Cereal leaf beetle sits there. Can't do anything because it's got this fecal coat over it, totally protected. All of a sudden, you know that the little cereal leaf beetle larva says, I got to eat something. Bends its head down, and the moment it bends its head down, there's a crack in the manure. Just a little crack. That wasp jumps on it, drops an egg down in the crack. And that egg will hatch and burrow down into the larva. And it sits there. Next slide. Sits there. Now you can see there's a larva that's been washed off to get the goop off of it. Just under the skin, there's a little wasp larva. And sometimes we would find 4 or 5 inside a cereal leaf beetle. Now, cereal leaf beetle continues its life cycle, continues to destroy the oats and the wheat and whatever it's doing, goes down into the ground, spins a cocoon. Now our larva begins to grow, eats out its guts, spins its own cocoon, and lays there until the exact time next summer there are more cereal leaf beetle larvae ready to be attacked. So it spends 50 weeks of the year down in the ground, waiting for just that opportunity to come up and eat this thing. And how does that evolve? Well, it can't. It's impossible. There's no way in the world something like that can evolve. Next slide. So, and yet, when I see that, here's an observation I made. If you're dependent on a specialized diet, like cereal leaf beetle, you don't have much chance of taking over the world, do you? I mean, if you're that dependent on one animal, you can't have large numbers yourself. By the way, on the cereal leaf beetle project, now you'd never see cereal leaf beetles. And the parasitoids just keep them at really suppressed levels. Neither one of them are a problem. It's total balance. Okay, next. So, what do you see more of? Look at this little critter. We all recognize it? Have them at your house last night? We did. Yep. We have raccoons everywhere. What's a raccoon eat? Anything. Absolutely anything, everything it wants to. Yep, sure does. Next slide. Here's a relative of a raccoon, they say. When was the last time you hit one on the road? When was the last time you saw one outside a zoo? What do they eat? What else? Nothing. Only bamboo. Which one do we have more of? We have more of the one that will eat anything. All right, next. Now, here's another observation. If you're dependent on the cooperation of any other living creature, you're limiting yourself. If I've got to depend on you to bring me food, and you don't show up one day, I'm going to starve. So if I've got to depend on some other living creature, I'm in trouble, or I'm limiting myself in some way. Next slide. So here we have a spruce forest. What do they depend on for reproduction? Nothing. The wind. There are spruce trees everywhere across this world in the temperate zone. Next slide. What else do you see that doesn't depend on anything? Grass. The grasses don't depend on anything for pollination or for reproduction except the wind. And what do we have more of? Grasses and trees, or, next slide, or pumpkins. Do we have pumpkins taking over the world? Nope. Next slide. Do we have apples taking over the world? Nope. You know why? Next slide. Because they depend on a honeybee. They have to have bees to pollinate them. They are totally dependent upon insects. If the insects were to die, you'd have no apples and no pumpkins. Next slide. And evolution is right about this. Just read the bottom line here for the sake of time. they believe that that plants figured out, get that? Plants figured out that insects could be duped into rendering a service, that is pollination, as long as they were offered a suitable reward. So evolutionists believe that the plants figured out we can make all these bugs. You know, the wind's doing a fine job, but we can make all these bugs do a worse job for us if we give them a reward. Well, wait a minute. Where's the fallacy in that thought? Chicken or the egg, that's right. What did the plants do before? Well, an evolutionist would say they relied upon the wind, and then they realized they could put all their energy into producing sugar and protein in the form of high-quality pollen. Right now, they're putting out a low-quality pollen, but a lot of it. And it's just dispersing and landing where it does, and yet the trees are able to prosper. So does the grass. Yeah, in other words, there's some kind of intentionality involved, that the plants figured out they could dupe the insects. Well, there it is, James Brackenbury in his book. That's what he said. 100 million years ago, the plants figured out they could dupe the insects. Amazing, isn't it? Saying that the plants can design, but there is no intelligent designer. So, I'm telling you, think critically about everything. Everything. Go ahead. Now I have to have a discussion about the birds and the bees. Okay. Isn't that a great shot? Next slide. There are several ways, if you're an organism, to increase your number. Okay? If you're a protozoan, you can just split in half. Okay? There's 1, there's 2, there's 4, there's 16, 32. Geometric progression. And you can do it in a hurry. In a matter of hours, you can go from 1 to millions. Next. Or if you're a plant, you can clone yourself. Strawberries will just send out a little runner, and the runner roots. It sends out a runner, and the runner roots. And in a season, it can take over a field. It's quick, but it's still the same paramecium. It's still the same bacteria. It's still the same strawberry plant. What if suddenly it turned cold and you need some diversity? You need some genetic intermingling. You need some variety. You need something else. Next slide. Oh, by the way, you can be born pregnant. That's another way to reproduce. Aphids, females are born pregnant. They're born pregnant. 3 days later, they give birth to babies of which they're born pregnant. Parthenogenesis. And they can go from nothing to having devastated your roses in 3 days. Population explosion. But they have a safeguard because every once in a while they will develop in boys and girls, and they'll mate, and now we have genetic diversity again. But if they just want to take over the world, they can do it fast. Okay. Well, now here's the fourth way. It's called pollination. Very time-consuming because you have to wait for a generation to occur for change and reproduction. You can put all the effort into attracting, or wind, but you put all the effort into developing a male and a female part, and you bring those males and female parts together, and they form a seed, and then the seed will germinate, and next season you'll have the progeny of that reproduction. Slow reproduction. So it's pollination, okay? What is pollination? All right, big explanation. It's boy parts, girl parts get together, either through wind or insects. Next slide. Insect pollination. Another observation. Insect pollination is a system of reproduction that exists in nature, highly complex, highly specialized, and extremely fragile. 1/3 of our food depends upon insect pollination. 1/3 of everything you eat depends on a bug. Millions of species depend on insect pollination for their survival, whether we eat them or not. Most of the flowering angiosperms depend on insects to reproduce. Somebody's got to pollinate them so they can have a seed. And if those insects die, they die. In evolutionary terms, this should not be. This should never have happened if you believe in evolution. We should all still be trees and grass, not depending on somebody else. We should be taking over the world. We should be being born pregnant, you know, because it's happened, right? Yeah, we know people like that, but not you. But evolutionary standpoint, this is nonsense. To be dependent on another organism for your existence and a slow reproduction, that's stupid. That's correct. You need to have the tree develop the fruit and the insects to develop the need, and they have to somehow come together at the same time. Right, or millions, right. Right. And even if you do, like, I have a brother who's an entomologist, and we've had debates about this, and he's like, well, it happens slowly. Don't you understand, you know, that it doesn't happen with this single species. It happens with this species, then this species. And it's like, yeah, right, Larry. Okay, go ahead. These are some of the crops that are pollinated by honeybees. All the good stuff. Next. Now, this is an orchid. It's a cool photo. I mean, I could have taken any one of 100 different examples or 1,000. But I like this orchid because this orchid is in Australia, and it's called a trigger plant. And this orchid depends 100% on one species of wasp to pollinate it. Only one in the whole world. Nothing else will do it. Not a honeybee, not anything else. So here it is. That defies evolution. So here it is. And the orchid doesn't want to be pollinated. I'm sorry. The orchid wants to be pollinated. So what it has done, it has evolved into looking like a female wasp and smells like a female wasp. I don't know what they smell like. But the male wasp comes along in his befuddled state, and he's smelling all these females, and he thinks that's a girl. So he grabs a hold, ready to reproduce, and when he does, next slide, there's a trigger, and as soon as he lands on it, this trigger smacks him in the back with such force that it sticks, you can barely see it there, but it sticks 2 pollen packets on his back and picks up any pollen he may already have. Hits him with such force that it throws him off the flower. He gets up, shakes his head, and goes, I smell girls. So he goes for another flower, and same thing happens. He gets knocked off. So for 2 full weeks, he does that, and he pollinates the orchids. When the orchids are done, then the female wasps come into play, and they do their normal thing. How did that evolve? Think about that. Isn't that ridiculous to think that that just happened? That one variety of orchid is dependent 100% on one variety of wasp? And they developed this really unique game of, I'm going to smell and look like your girlfriend. And yeah, and then I'm going to smack you. Next slide. This is another bee we have in the United States. This is the blue mason bee. They're really common, and they're a great pollinator. You know, with the problems with honeybees, this one's been promoted as an alternative. One mason bee can do the work, really can, of about 100 honeybees. And the reason for that is because honeybee won't start working until it's about 55 degrees. And this mason bee goes, hey, if the sun's shining, I'm out working. And they get out there and they work. They start earlier in the morning and they stay later at night, and they just work themselves to death. What I find interesting about the mason bee, go ahead, is that you only see them for about 2 weeks of the year. Then they're gone. And what happens to them in the meantime? Well, you can set up a mason bee nest. This is an example of a really nice one. Or you can put up a bunch of soda straws wrapped in a rubber band and hide it in a tree. And they'll use that as a nest. Go ahead. And what they do is, let's start in the spring. In the springtime, the mason bees come out of those nests, and the females come out, reproduce, and immediately start pollinating because they're looking for pollen and nectar to build a nest, and then in 2 weeks, they're dead. The females are dead. Well, let me tell you, it's a little bit that I find amazing about the mason bee is that this is the inside of one of those nests, cross-section, and they usually put 6 eggs in each one. They put the first egg in the back, and they do that by the female will go out, pollinate a bunch of apples or whatever, and she'll bring back nectar and pollen, and she builds up a ball of nectar and pollen until it's nice and big and moist, and then she lays 1 egg on it. She puts in a wall of cellulose. She'll get it from plants. She puts in a wall, completely seals it off. Next day, she goes out, does it again, makes another big ball of pollen and nectar, and she'll lay 1 egg on it. She'll do that until she has 6, maybe 8. And meanwhile, the egg hatches and the larva is feeding and developing, and it forms its own little cocoon. It goes to sleep until next spring. And next spring, who hatches first? The last one that was laid, always. Because if it doesn't, if you're the first one laid and the first one out, you're going to burrow through your buddies. So even more amazing is that the first ones to hatch come out early than the last ones to hatch, and the first ones to hatch are always boys. Back up 1 slide. So the boys will hang around. Now, mason bees are gregarious. They don't form a colony, but they don't care about each other. Each little slot will be 1 mason bee, perhaps. Doesn't care about the other slots. They're gregarious, but they're not social. And those males will come out, though, in the spring, and they will hang around on the outside, and they just wait. And the female comes out a couple days later, and when the females all come out, only when there is bloom, the males they're mated immediately. The male dies. The male mason bee who's been sitting in that nest for 50 weeks, he dies immediately. The female goes out, starts new nests. She does it all over again. She does her pollination thing, and then she dies. He doesn't even live for that. She lives for 2 weeks. And then he dies, right. He doesn't do any pollination, right. His only function is to breed. But the outer 2 will be boys, always. And they always come out first. How did that evolve? I'm amazed by some of this. It takes more faith to believe that than it does to believe, oh, God did it. It's a better explanation in my mind. Okay, next slide. 2 slides. These are honeybee colonies. You're all familiar with those. I have bees. I've had bees since I was 12. Pretty heavily involved with beekeeping. Next slide. And the mason bee comes through the winter as a virgin queen and a dumb drone, and they can't build up populations. Even though they will do a lot more pollinating per bee than a honeybee, simply don't have the pollination abilities that honeybees have. Honeybees will come through as a colony. They'll come through as a colony of 5,000 or 6,000 bees. Now you've got 5,000 or 6,000 bees on the first warm day going pollinating things, doing their thing. That's the beauty of the honeybee. Next. At the very top above my finger there's a queen bee. This is in April, and she, in April, is laying a couple hundred eggs a day. In July, she'll be laying 2,000 to 3,000 eggs a day. Mason bee, 6 her whole life, maybe 8. Which one is better? Which one is better for pollinating our crops? Well, it's the honeybee, of course. Next. You've all heard about a bee dance? That's another fascinating thing that I've watched 1,000 times in the beehives. Not that. But, next, a guy named Karl von Fritsch back in the 1940s in Germany was watching bees, and he was trying to figure out how does a bee in a dark colony tell its buddies where to go for food. So he set out little flasks of sugar water, and he would observe bees, and he made his career out of this. And really good. I was reading his book last night, translated into English. It's fascinating. He discovered so many cool things about honeybees. You know, they're in this dark hive. When the bees are broken down into castes, okay? You're born a nurse bee, you become a forager. Nurse bees don't forage, forage bees don't nurse, okay? Very distinct classes of bees. And a few bees are scout bees. The scout bees go out with a full stomach of honey. They're very, very efficient. They go out with a full stomach of honey and they're looking around for food. They don't care. They don't have a plan. They find a flower, or they find Karl von Fritsch's little jar of sugar water, and then he would put a dot on them with paint, and then he would watch them go back into his observation hives, and he'd see what they would do. And they'd go and they'd do this dance. And the angle related to gravity is exactly the same angle as the bees leave towards the sun. Does that make sense? So if up is the sun, this bee will do a waggle dance, and the angle of that waggle dance is the exact angle that they have to fly in relation to the sun. He discovered that. The amount of waggles they do per their interval shows the amount of nectar that's available out there. The bees that are surrounding that forager bee, they're actually smelling. They're taking little samples of smell off of what that bee was working. And they're like processing it. And then they take it and they give it to others. Now, these bees, these forager bees leave with just enough honey, nectar in their stomachs to get there. If they get there and they were lied to, they die. Think about it. It's like a cargo plane. You don't want to be filled full of fuel when you're on your way to get fuel. You want to go with just enough to get there, come back with a full tank. The honeybee takes off with just enough fuel, no reserves, to get there. Gets there, gets the nectar, fills up, comes back, And when they do, some of them will, if it's a great crop, they'll do a waggle dance, and the whole colony gets excited, and they go off and they start doing their recovery of the nectar. Amazing research that this guy did, and he did lots of things with ultraviolet light. What's a bee do on a cloudy day? Well, they see ultraviolet. They can still see the sun. They know exactly where the sun is through clouds. And I could talk all day about this, all the research he did. It was really fascinating. He put barriers up. He put them around mountains, and the bees could figure out they can do a type of trigonometry. They can figure out the angle, even though they have to go around an obstruction, and they know where their destination will be, and they can figure out that distance. It's how? I can't do that. Yeah.
How does this communicate to the other bees? By sight or vibration? How are they getting the message?
They are, all those bees that are surrounding her, there'll be 4 or 5 who will get the message from her, and then they go and tell 4 or 5 with another dance. Right. That's right. Yep. And they'll just tell enough, in relationship to the crop that's available. Now, that's really interesting. Another side point that I think is interesting is that the bees go out, and what would happen if the bee worked a dandelion and then worked an apple? Is that dandelion going to get pollinated? Nope. So they become a monofloral mission. If you send me out to work apple, I'm not going to go and work dandelions. I'm going to work apple until the apples are done. And if I'm starting on dandelions, I'm not going to apple. So that's why you'll see orchard guys cut the dandelions on the floor of their orchards because they don't want the bees going after the dandelions because they won't go up to the apples. And another really interesting thing is that there is no pollen that is a complete food for the bees. It's their protein source. They have to blend pollens together in order to get a complete meal. So bees will not work just dandelions because they're missing at least 1 or 2 amino acids, which they can pick up from apples. So today we're going to work willow, tomorrow we're going to work dandelion, or we're going to have people working all of them and that pollen comes in and it all gets mixed together. A complete food. It's pretty amazing. I was talking to a professor at Grand Valley where she's doing a research project on pollen, and I'm kind of helping her with that, and we're going to do a bigger project next year where we're going to analyze the pollen for its protein content because I think bees are starving to death even though there's pollen out there. I think they're not getting all the amino acids they need, and she totally agrees with it. She's applied for a grant, and she got a mini grant this year, and she's looking for a major grant next year. But I think that because there's such a small diversity left anymore for the bees to work that they're starving to death, or they're malnourished. If all you ate was potatoes, you'd be sick.
Less diversity in bees or less diversity in vegetation?
What's that?
Less diversity in the pollen or less diversity?
There are fewer plants, yeah, and monocultures, that's right. If you're working nothing but almonds, they've known for years that if you send your bees out into almonds, that they're going to come back sick. And they're thinking now that it's a protein that they're missing from the almond pollen. All right, we've got to hurry up here. Next. Yeah, Lori. I'm sorry? Good. You know, that's right. Why don't they adapt? Oh, that's a great question. Why don't they adapt to eat just potatoes or just one? Maybe they will. Maybe they will. Good question. This has happened so quickly, too, over the last few years, really since the 1940s, 50s. Okay. Oh, and there's a whole thing about genetics of honeybees, too, we won't get into. We'll go on because we're running out of time. Just skip this. Interesting, though. This happened to be a colony of bees in almonds, where almond production will use every single hive of bees in the United States. The limiting factor to almonds in the United States is honeybees, not land, not water, not anything else, but it's honeybees. There aren't enough bees to pollinate. And in this particular case, I happen to be familiar with this because the almond grower sprayed while the bees were pollinating his crop. What an idiot. And these are some of the dead bees that were a result of that. He'll never get another beekeeper to pollinate again. I know a guy, Richard 80, out of North Dakota. Richard 80 has 80,000 hives of bees. Every single one of them goes into almonds for pollination. And he has raised his rates this year to $200 per colony. He doesn't care about honey anymore. $200 times 80,000. Do the math there, Brad. Is that 16 million? Just on pollinating almonds. And then he takes his bees and he pollinates blueberries and apples and everything else. But he said it's not worth it. If they're not willing to pay what I want to charge, I'm not taking my bees in anymore. So the almond growers are going, okay, $200. He's changed the whole industry, Richard 80. You know, I used to take bees for pollination. I got $25 a colony. Yeah, nasty, stung up. Not fun. Okay, next. So we're drawing this to a conclusion. Sleeping? Nope. Nope. And I don't want to sound like an environmentalist here because I'm not, but all right, next slide. Yeah. There's a message you can go away with besides the message of God and His creation. Next slide. So I have to throw a scripture verse in here, Romans 1:20. Can't read that. Bad eyes. There you go. His invisible qualities are clearly seen from the world's creation onward because they are perceived by the things made. Romans 1:20. So I'm going to conclude that because we're now out of time. But entertain questions if you have any. None? Okay. Tony.